In this video, we are going to be talking about single-step conversions. Now, before we start talking about our conversions, we need a few reminders. So we're going to start out with reminders. And the first reminder that we need is if I see one of the following if I see one of the following elements by itself, and whenever I say by itself, I mean not in a compound or with another element. Okay, so again, if I see one of the following elements by itself, meaning it's not in a compound or with anything else, and those that I'm talking about is what I call Brinkelhoff. So, bromine, iodine, nitrogen, chlorine, hydrogen, oxygen, and fluorine. So these are known as the diatomic molecules, okay? And if I see them by themselves, okay, so if I were to see the word bromine written, okay, typically we would be like, oh, it's Br. But it is part of Brinkelhoff. It's one of those diatomic molecules. It's going to be Br2. Okay, so that means that I would have 2 Brs instead of just one. Okay, and then let's say, for example, we were looking at nitrogen. So, if I see just the word nitrogen by itself, then that's going to be part of this Brinkelhoff where we're going to have N2. But if I saw nitrogen dioxide, then that's going to be NO2. Okay, so again, this is going to be important for whenever I'm having to find molar mass. So if I see just the element name by itself for any one of these Brinkelhoffs, then I have 2 of them. If it's with something else, then I just go with the way that it is written. So nitrogen dioxide, since nitrogen is first, I have 1 nitrogen. Okay. Other reminder that we need is our good friend, the guess method. So G is for your given, U is for your unknown, E is for your equation, but in this case, we're going to be doing conversion, so we're going to be converting from one thing to another. We're going to have our unit path. S is our setup, and then our last S is to solve. Now, this is going to look very, very similar to what we did with our dimensional analysis. It's just now we're using molar mass and the mole with our conversions, okay? Other thing now is we're going to make a chart, and this chart needs to be on its own separate sheet of paper because we are going to be referring to this a lot over the next little bit, and it is very important that you are able to keep up with it as well. So, in the middle of our chart, we're going to have moles. Then on the sides, we're going to have grams, which let me do a brighter color blue. And then atoms, compounds, molecules, particles, and formula units. Now, there are more words over on the right-hand side because I could say any of those things. I could say atoms, I could say compounds, molecules, particles, formula units, but I'm still going to solve the same way. Okay? So, here's where the chart comes in. If I am going from moles to any of these atoms, compounds, whatever, then I'm going to multiply by Avogadro's number. That's 6.02 times 10 raised to the 23rd. Okay? And whenever I do that, my conversion factor will be that 1 mole equals 6.02 times 10 raised to the 23rd, whatever. Whether it's the atoms, the compounds, molecules, whatever will go in that blank. Then, let's say if I were going to go from moles to grams, then I'm going to multiply by molar mass. So my conversion factor for that is going to be blank grams equals 1 mole. Because we've talked about the fact that molar mass is literally the mass of 1 mole of whatever our substance is. Okay? And then, if we are given grams and we're going to moles, then we're going to do the opposite. We're going to divide by our molar mass. And then if we are going from atoms, compounds, whatever, to moles, then we're going to divide by our 6.02 times 10 raised to the 23rd. Okay? So again, this chart is going to be your best friend for the next little bit. Okay? And I'm going to refer back to this chart. Okay? So, let's use our chart now to do an example. So, example 1. And this is going to be how many molecules are present in 3.5 moles of sucrose. Okay, well, we use our good friend the guess method. So we start out with our given, and in this case, we're given 3.5 moles of sucrose. Then we move on to our unknown. And our unknown is the thing that we're trying to solve for. So in this case, we're trying to figure out how many molecules of sucrose. Okay. Then our next part is the E, which is going to be our unit path. So, since I'm given moles, I'm going to start with moles, and then I'm trying to get to molecules. And if I come up here and I look at my chart, I have a one-way arrow of going from moles to molecules. So, moles to molecules. And if I come back up here and look, if I follow my arrow, I'm going to be multiplying by 6.02 times 10 raised to the 23rd. Now, I like to write that above my arrow because whenever I multiply, that's where that 6.02 times 10 raised to the 23rd is going to go in my fraction. It's going to go on the top. So what that means whenever I do this is my conversion factor is going to be 1 mole equals 6.02 times 10 raised to the 23rd molecules. Okay. Then we're ready to do the actual setup. So whenever I go to set this up, I always start with my given, which in this case is going to be 3.5 moles of sucrose. And if I start with moles of sucrose on the top, that means that mole of sucrose has to be on the bottom, and then my molecules of sucrose will be on the top. Okay? So again, whatever's on the top has to be on the bottom in order to cancel out. And then we plug in. Now, when we are doing single step conversions, the 1 will go with the mole. And then my 6.02 times 10 raised to the 23rd will go with the molecules. And I want to show you how to type this in on your calculator. So you're going to do everything on the top, divide it by everything on the bottom. So that would be 3.5 times 6.02 times 10, and then you're going to use the little rooftop or caret key to do the 23rd. Now, in this case, we're dividing by 1, so we don't necessarily have to type that into our calculator. And whenever we do type this into our calculator, your calculator is going to give you 2.107 E plus sign 24. So first off, you have to round to 2 decimal places. So this is going to round to 2.11. The E means times 10. And then this right here is your exponent. The positive sign or the plus sign means that it's a positive 24. And then molecules of sucrose. Okay, so again, the big thing with this is remembering whatever's on the top has to go on the bottom and then knowing which numbers go where. Okay, so what I want you to do is I want you to try working example 2 on your own. Okay, and then come back to the video and see how you did. So example 2 is how many moles of zinc are present in 4.50 times 10 raised to the 24th atoms of zinc. So again, we start out with our given. In this case, we're given 4.50 times 10 raised to the 24th atoms of zinc. Then what we're trying to find is how many moles of zinc. So that's going to be our unknown. Our E is our equation, or in this case, our setup. So I'm going to go back to my chart because I know that I'm starting with atoms, but I've got to see if I start with atoms, then I'm going to follow my blue arrow to get to moles. And whenever I do that, I'm now going to divide by 6.02 times 10 raised to the 23rd. So we're going to go to moles, and we're going to divide by 6.02 times 10 raised to the 23rd. And again, I'm putting that on the bottom because that number, that Avogadro's number, is going to go on the bottom of my fraction. So that's why I write it in that way. And then remember that 1 mole equals 6.02 times 10 raised to the 23rd atoms. Okay? And then we're ready to do our setup. So in this case, we're going to start out with our 4.50 times 10 raised to the 24th atoms of zinc. If I start with atoms of zinc on the top, that means that atoms of zinc has to be on the bottom, and then mole of zinc will be on the top. Okay? And notice I did that without plugging in any numbers. Okay? Then we plug in. So, if you remember, when I just wrote this, I told you I wrote it on the bottom because that 6.02 times 10 raised to the 23rd goes on the bottom of my fraction, and the 1 goes with the mole. Okay? And whenever we solve this, and you type it in your calculator, you're going to get 7.47508. We round to 2 decimal places. We're going to get 7.48 moles of zinc. And you do have to tell me what you are talking about. So you can't just say 7.48 because then I won't know what you're talking about. So you actually have to tell me moles of zinc. Okay, so let's do another example. And I want you to try this one on your own. It is, how many moles would there be in a 18-gram sample of carbon? Okay, so how many moles would there be in an 18-gram sample of carbon? So, we start out with our guess method. So, our G is our given. We are given 18 grams of carbon. Then, our unknown, what we're trying to find in this case, is how many moles, and specifically moles of carbon. Then we move on to our unit path. So this time we're starting with grams. So we've got to scroll back up to our chart. We're starting with grams, and then we're trying to get to moles. So if I follow my pink arrow, I can do that. And the way that I do that is I divide by molar mass. So we're going to go from grams to moles, and we're going to divide by molar mass. And remember, I'm writing that on the bottom because that means that that's where it's going to go in my fraction. And so in this case, we're going to have so many grams equals 1 mole. So again, the number 1 is going to be with the mole. Now, if I'm dividing by molar mass, that means that I actually have to find the molar mass. And so we have carbon, we have 1, its mass is 12.01. So that means 12.01 grams per mole of C. That's not new, okay? But I can take this and I can write it as 12.01 grams equals 1 mole. Because we know that. We know that a mole of carbon is going to weigh 12.01 grams. Okay? So then we go through and we do our setup. And we always start with what we're given, which in this case was the 18 grams of carbon. If I start with grams of carbon on the top, that means that grams of carbon has to be on the bottom. And then what I'm trying to get to, which is moles of carbon, will be on the top. Then the 1 goes with the mole, and the 12.01 goes with the gram. And if I type this into my calculator, then I'm going to get 1.50 moles of carbon. And that would be my answer. Okay. Now, let's do an example of the opposite. Let's say that we're given moles and we need to convert to grams. So, example number 4 is how many grams would be present in 10.4 moles of AlOH3. So again, we always start with our given, which in this case is our 10.4 moles of AlOH3. Then we go to our unknown. What is the thing that we are trying to get to whenever we convert? And in this case, it's how many grams of our Al, aluminum hydroxide. Okay. Then we do our unit setup. So we're going to start with moles. And then we're going to go to grams. So if I follow my orange arrow, if I start with moles and go to grams, I'm going to be multiplying by molar mass. So from moles to grams, we're going to multiply by molar mass. And again, I'm putting it on the top so that I know in my fraction that the molar mass, that gram part, is going to go on the top. And so since we need molar mass, we have to find the molar mass. Now, I'm not going to show the mass numbers from the periodic table. I trust that you can find those using your periodic table, but I will show the work for finding the molar mass. And then we have 3 hydrogens. They're 1.01. So 26.98, 48.00, 3.03. We add them all together and we get 78.01 grams per mole of aluminum hydroxide. And remember, this can be written as 78.01 grams equals 1 mole. And that's what we're going to use for our conversion factor. So when we go to set this up, we're going to start out with what we were given, which was the 10.4 moles of aluminum hydroxide. If mole is on the top, then that means that mole has to be on the bottom. And then what we're trying to get to, which is grams, has to be on the top. And then I want you to remember, for what we are doing right now with our single step, the 1 will go with the mole. So 1 and then 78.01 grams. If you type that into your calculator and round to 2 decimal places, then you should get 811.30 grams of aluminum hydroxide. Okay? And again, this isn't necessarily something new. We've done conversions before. It's just now using the mole and molar mass and Avogadro's number as in our conversions. And that is it for these notes.